Okay, so we've been looking at our natural logs and E. Okay, this question here, it uses E. Okay, other than the fact that it uses E, we actually don't need to rely on natural logs that much. Okay, if we actually understand our logs well, then this question is fine. It is very wordsy, so the first thing I'm going to do is I'm going to take out my highlighter, okay, so that I can highlight the key pieces of information. So it says, a company produces firewood. To make firewood, the company cuts the wood and then leaves it in a warehouse to dry out. The water content of the wood, W of T, is the percentage of firewood that is actually water. Now that's a key part of the question, I would say, because there's a chance that they'll look for a percentage of firewood that's actually water, or that they might give you the percentage of firewood that's actually water. So I'm going to highlight that if they give that to me, they've actually given me W of T. Okay, the following equation describes the water content of the wood while it is drying out, and that is it there. Okay, T is the time in weeks, so they might give me time in weeks, or they might ask for it. Okay, or maybe they might give me time in a different unit, and I might have to convert it to weeks first. Okay, from the start of the drying process. It says T is a real number. Okay, that's fine. So time, it doesn't have to go up in full days. Okay, we might have parts of days. And it's greater than or equal to 0. So we're just starting from the start and going forward from there. Okay, so we're never going to go back in time where T is a minus. So use W of T to answer parts A to E. Now I think we're only going to focus on A and B here. It's kind of the only parts that have to do with logs. Part A says work out the water content of the wood at the start of the drying process and after 8 weeks. Give each answer as a percentage, correct to the nearest percent where appropriate. Okay, so there is lots in that there. Okay, the first thing, work out the water content of the wood, okay, as a percentage. So here, the percentage of wood that's actually water is W of T. Okay, so I'm going to be using W of T for this. Okay, so that I get, so 5 plus 20 e to the power of minus 0.079t. Okay, so this is going to give me my answer, but I need to know what to fill in for t. So what time is it at the very start? Well, if you think about a very start of a stopwatch, okay, it's literally at 0. Okay, so at the very, very start, t is going to be 0. So I'm going to fill this in where I'm going to fill in t as 0. So that I get 5 plus 20 e to the power of minus 0.079 times 0. Okay, now I could almost do this in my head because I know that it's 5, where's my thing gone? 5 plus 20 times e to the power of 0 when we do out this multiplication. So anything to the power of 0 is 1. So it's 5 plus 20 by 1, which is 25. Okay, now if you didn't do it in your head, that's fine. You can just type this full. As soon as you've subbed in for t, you can type that full thing into your calculator. Okay, so that is it after 0 times or weeks. Okay, so at the very start of the drying process, there's 25. Okay, it asks for it as a percentage, correct to the nearest percent. Okay, so I'll just write in my percentage symbol there because it is as a percentage. Okay, so if you didn't get that one, you could pause the video now and try this next one. Okay, after 8 weeks, what would you do? Okay, so again, I'm using my same function, so I'm going to write it down. Okay, and then I see that it's after 8 weeks, so t, okay, is the time in weeks from the start, so 8. So I'm going to be filling this in, where I'm going to fill in t as 8. Okay, so t is going to be 8. So it's multiplying by 8. Okay, I can't do this in my head, so I can just throw it all into my calculator. Okay, so that I get 15.63%. Okay, and then again, I go back, I reread the question, give each answer as a percentage, correct to the nearest percent. So I'm going to write it as, and I'm going to approximate this here. Okay, 16%. Okay, that's after 8 weeks. So those squiggly equals is just because it's an approximation there. Okay, So the next question then says, the company will sell the wood once the water content is 10% or less. Okay, so content is 10% or less. Work out the least number of days that the wood must dry out to ensure that the water content will be below 10%. Two ways I can do this. Okay, I could absolutely say, okay, when is the water content going to get to exactly 10%? Okay, and whenever it gets to exactly 10%, I'll go to the next full day. Okay, so that's one way of doing it. Okay, so if I wanted to get when it gets to exactly 10%, okay, so I could say, so when is it exactly 10%? It's when it's equal to 10. Okay, so I could do it that way. Okay, the other way you could do it is to solve it with a less than or equal to symbol. Okay, so that you could, again, rearrange. Remember, we rearrange the exact same way with an inequality as we would with an equals, except if we multiply or divide across by a minus. Okay, so I'll start it as an inequality. Okay, maybe I might go through it with an equals as well, but let's do it as an inequality first. Okay, so the first thing I do is get rid of this 5. Okay, so I'm trying to get t on a side by itself, and the t is in the power. So I have to get rid of a few things here. Okay, my ideal situation, because it's logs, is that I'm going to end up using my log rule to get that out of the power. Okay, so I'm going to end up using that. If I have something in the power, I can get it out of the power using my log rule. Okay, that's what I'm going to have to use here. Okay, but to do that, that has to just be one, like a power, that's fine, acting on one piece of this. So I have to get rid of the 5 and the 20. Okay, so whatever the power is acting on is fine to stay there. So the A had the X acting on it. Okay, so the X was a power on the A. So the A can stay there. Likewise here, all that's a power on the E. It's not a power on the 20 and it's not a power on the 5. So I have to get rid of those before I can use this rule. So I'll get rid of the 5 first by subtracting 5 from each side, so that I get 20e to the power of minus 0.079t is less than or equal to 10 minus 5, so 5. Okay, and then I'll also get rid of the 20 that's multiplying, because again, the power isn't acting on the 20, so I need to get rid of it before I use my rule. So I'll divide by 20. Why did that just change to black? So divide by 20 there. Okay, and then that way I get e to the power of minus 0.079t is less than or equal to 1/4. Okay, now I am trying to get t on a side by itself. This is the part that's new to us if we're using an inequality. Okay, I can't be moving the side that t is on, otherwise I have to switch the inequality around. So every time we've done inequalities, we've kept x on the same side. Otherwise, if we swapped sides, if I had something like x is greater than 2 and I decided to put x on the other side, the inequality would also have to switch. Okay, so here it can get a little bit confusing, okay, but what we want to make sure we do is keep this t on the same side. Now, to do that, how could I get rid of an e? Okay, look at our rules here. I could use this rule and introduce the log with a base e. Okay, so to rearrange it, okay, all I need to do is I need to make sure that this power part, the x, okay, is staying on the left-hand side. So when I rewrite it and I use this rule, okay, so if I use my rule, then I want x to be now on a side by itself. So the old power is now going to be on a side by itself. Okay, and then I can do the inverse of e, which is a log with a base e of 1/4. Okay, what's another way of writing log with a base e? Okay, another way of writing log with a base e is our natural log. Okay, so my natural log there, my ln, So if I wanted to write it out a different way, I could write it like this. T is less than or equal to ln of 1/4. Okay, but I've kept T on the same side. Okay. Now I am looking for T. There is still something in the way of having T on a side by itself. It is multiplying it, so I can divide across. I could put into my calculator ln of 1/4, but it's going to give me a really long decimal, and I don't want to write out all the decimal places. So I'll probably just leave it as ln 1/4 until the very end. Okay, so I can't write in ln of 1/4 into my calculator and round it, because that will affect my final answer. Okay, so I don't want to round this. Okay, so I'm actually going to leave it as ln of 1/4 just to keep my answer as accurate as possible. And I'm going to get rid of what was multiplying the T. Now, when I do this, remember you've divided by a minus, which means the sign, a bit of inequalities revision, the sign has to change direction. Okay, then I can put this full thing into my calculator and it will give me 17.5480298. Okay, weeks. Oops. Weeks. Okay, so that's how many weeks. So it doesn't actually ask for the time in weeks. Okay, I know I've found the time in weeks because T is the time in weeks. Okay, this one says the number of days. So if that's the number of weeks, again, think back, how do I get from weeks to days? Okay, even just write a little note to ourselves. 1 week is 7 days. How do I go from one to the other? What do I multiply by to get from 1 week to 7 days? I multiply by 7. Okay, so to get from weeks to days, I'm going to multiply that answer by 7 so that I get T is greater than or equal to 122.836292 days. Okay, and they want the least number of days. Okay, so here, even if that was 122.1 days, okay, it's not ready at the very start of the 122nd day, it's not ready to sell. Okay, so 122 days in, it's not ready to sell, but by 123 days, it is. Okay, so T there is 123 days. Now, if we had done that with an equality the whole way down, okay, we literally would be getting to, so there was the only place there where I had to say, okay, T is greater than or equal to 122.83. Okay, so the nearest whole number to that, okay, not even the nearest, sorry, the next whole number that T can be, if it's greater than or equal to that, there was no way I could go down. Okay, so if T is greater than or equal to 122.1, I cannot say that T is equal to 122 because T is greater than or equal to 122.1. So I knew I was going to have to go up from that. If I had done the whole thing as an equals instead, okay, I would have just had to recognize that at the very end, that the exact time that is it's 10% is 122.836292 days. Okay, is exactly when it hits 10%. Okay, and they can't sell it at that time, so they have to wait until the following day when it's further dried out. So that we would say 123. Okay, so you could have done it with an equals there, especially if this part here with the changing signs was confusing. Okay, but overall 123 days, and if you got to the end 122.83, you might have noticed if your sign ended up being the incorrect way around, because you would have known to have to go up to the following day. Okay, so it is useful to read our questions and actually think about them logically as well, so that we do recognise that we have to go up there to the following day.